All right, we are moving into chapter 6. Really not too bad. It just has kind of a lot going on. There's a lot of different concepts revolving around square roots. So here are my notes, and you can feel free to pause this to make sense of them. I'm not going to walk through all of them because there's a lot. So you can get the gist of what my little notes mean with each example. Hopefully it makes a little more sense than what the book tells you. Variables under the radical, rational numbers as exponents. This is where it'll get kind of tricky, but once you understand the concept, just know that bottom number is your root. The top number is, you treat it just like an exponent. So whatever the bottom number is, that is your root. So 1/3 means cube root of. Half, that's nice because that's just a square root. When you see half, when you see a 2 in the denominator, you know you're dealing with a square root. This one just means 1. Now, if that was a -1/2, you'd still have this same thing, but you'd flip it because you'd leave it to the -1. I'll do a couple of those. And then here's a bunch of examples on the back. These are nice. I worked these in class to show that sometimes it's simple enough to just say, okay, cubed root of 8 squared and do the work. However, sometimes we get numbers that make that a mess. If I clean this up so that it looks like my 2 is the square root, and if we say square root of 25 cubed, well, we have to cube this 25 first and get the square root of it. However, if we leave it in fraction form, then we can say 25 to the 1/2 cubed. If we just pull out the half and leave our exponent, well, now we can just find square root of 25, which is 5, and cube it. Much easier. Same down here, a 9. I want the square root of 9, which is 3. I want to deal with that. So I'm going to pull the square root out and say, well, that's square root of 9 to the -3. So then I know I'm moving it down to have it cubed. If I leave my exponent with the number, I got a big number again. However, if I just leave it as 9 to the 1/2 to the -3, now I know I'm dealing with the square root of 9 to the -3. So I put it on the bottom, and I have square root of 9 cubed on the bottom. Okay, so those are the examples. Then we get into a little added division. Let me work a few for you because that's what's going to be most beneficial. So I'll work number 19 real quickly. I'll break this one down. You don't have to. You can get to where you just say cube root of that, cube root of that. But you can view the cube root of 27 as 3 times 3 times 3. I won't break them all down like this. But what you're doing is every time you have 3 of something, I'll just say pull one out, pull them all out, but think 1. Okay, pull 1 out. And then you divide 12 by 3. So you have a to the 4th times a to the 4th times a to the 4th. When you're dealing with exponents with a variable, you divide by the root. Divide by that. 12 divided by 3 is 4. I know I have 3 of these. So for every 3, you pull 1 out. So what happens is I pull out a 3, they're all gone. If there were 4, I'd leave 1 3 in here. Now there's 3 of these, so we have a perfect cube. We have 3a to the 4th. The cube root of this is 3a to the 4th. Now, I didn't leave myself room. That was dumb. But I know this is a negative. I'm going to write it differently first. I'm going to say it's a negative 9 to the 1/2. What we're dealing with is, like, if I say -2 squared, well, I know 2 squared is 4. 2 squared is 4. That just says -4. 2 squared is a fancy way to write 4. Same here. 9 to the 1/2 is a fancy way of writing square root of 9. 9 to the 1/2 is square root of 9. They're saying it's a negative 9 to the 1/2. A negative square root of 9 means a -3. Then 38, 9/16 to the 1/2. Don't let it fool you that there's a fraction and a fraction. We have a fraction raised to a fraction exponent. Just this one's easy enough to think in terms of 1/2 means square root. So I'm dealing with the square root of 9 over to the square root of 16. Anytime you have a fraction raised to an exponent, you apply that exponent to both the numerator and the denominator. So the square root of 9 is 3, square root of 4, or 16 is 4. Now here what I want to do is I want to just pull the 2 out because I don't want, the negative can throw people off. You know you're moving something, but it becomes more clear to see what you're moving if you pull this 2 out first. Again, I know 2 is the square root. So what I have is the square root of both of these raised to a -1. Now I know that means, and you can do it and then flip it. You can do the work and then flip it. But what that means is I'm flipping them. I have this one is negative, this one is negative. I've got to move them to make them positive. So I have square root of 49 over square root of 16. Again, in algebra, man, it's windy today. With algebra, we leave improper fractions. We are not concerned with them. Now here, we're going to do the same thing as we did up here, but we're going to add. So there's another step. So I have 49 to the -1/2. What I'm going to do, I'll take you through the steps. I know that square root of 49 to the -1, and I'm going to add square root of 25 to the -1. That means I actually have 1 over the square root of 49 plus 1 over the square root of 25. That becomes 1 over 7 plus 1 over 5. What happens is I need my LCD, and I should have left just a touch more room. I need my LCD. With 7 and 5, my LCD is 35. That means I'm multiplying 5 here and 7 here. 5/35 is 1/7. 7/35 is 1/5. I can fit it in here. 12/35. We add them together. There's our answer. Okay, and again, I'm not stopping to pause too much because you can pause the video if you need to. A to the 2/3 times or raised to 3/4. Treat it like you treat the exponent rule. Use the exponent rule. Exponent raised to an exponent, you multiply the exponent. A to the 2/3 times 3/4. When it's raised, when an exponent is raised to an exponent, that's when we multiply them. And I'm going to cross cancel. 3 goes into 3 once. 2 goes into itself once. It goes into 4 2 times. I have a to the 1/2. We know that square root of a, but we're going to leave it a to the 1/2 because we started with fractions. We're going to leave it in fraction form. Okay, now this one, same rule. We use our rule of exponents. When I have an exponent, x to the 3/4, my hand's covering it, sorry, raised to an exponent, we multiply. And I'm going to go right down the list. Y to the 1/8 times the same exponent, 4/5, times z to the 5/6 times an exponent, 4/5. This exponent applies to every one of these. So we multiply by every one of them. So now when I do that, I cross cancel. The 4's cancel out here. I'm left with x to the 3/5. Here, my 4 cancels in here. I'm left with 1 times 1, 2 times 5. So y to the 1/10, and then I'm going to have z to something. My 5's cancel out. 2 goes into 4 twice, into 6 3 times. So z to the 2/3. All right, so we just did how many? 1, 2, 3, 4, 5, 6, 7 of the problem set pretty quickly. Once it clicks, once you understand the concepts here in 6-1, these actually go pretty quickly. So hopefully you don't mind these. I actually think 6-1, I don't know, 16, I think 6, well, I don't know, I can't say that. I was gonna say 6-1 might be the most complicated because you learn a lot of different concepts together. And then after this, the coming sets focus a little more on 1 or 2 concepts. So hopefully you like that.